Okay, we are on lesson 18, part 2. We are going to solve using the quadratic formula. And the reason we need this is you can't always find the solutions by factoring. Remember when we factored that we would try to come up with a common binomial, and that common binomial became the first binomial, and the pieces became the second binomial. If you don't get a common binomial, then it's not factorable, and you would have to solve by some other method. Normally, when that's the case, you have a square root in the answer, a rational answer, an irrational answer, excuse me, or an I in the answer. The square root of -1 pops up. And to see those types of answers, we need to work it out on paper. If you punch that in the calculator, it's not going to give you an imaginary result or a radical result unless you have a fancy calculator that's programmed to do that. But anyway, so we want to solve these using the quadratic formula to learn how to do that. And as we do, we're going to pay some special attention to this portion of the quadratic formula. And we'll use that. It's called the discriminant, but we will use it to try to think about how the answers are going to come out before we even finish, okay? And we'll try to verify that with some graphics stuff. Okay, so number 11, the a of the quadratic is 1, the b of the quadratic is 5, and the c of the quadratic is 6. So a equal 1, b equal 5, and c equal 6. And so we have x is equal to the opposite of the b value. The opposite of a positive 5 is a -5, plus or minus the square root of my b value, which is 5 squared, minus 4 times a of 1 times my c of 6, all over 2 times the a of 1. Everybody say we got that. When we solve, there's 3 things we will do first. We will square that, we will multiply all of those, and we will multiply those 2. We're going to do those 3 things. And so we will have x is equal to -5 plus or minus the square root of 5 squared is 25. Now on the next part we need to be careful. We're doing all 3 of those, and we're multiplying. So we need to know our odd-even multiplication rules for signs. First of all, 4 times 1 is 4 times 6 is 24. The 4 is negative. It's the only negative. When you multiply or divide with an odd number of negatives, the answer is negative. And if you multiply or divide with an even number of negatives, the answer is positive. That was an odd number of negatives, so the answer is a -24 over 2 times 1 is 2. Let's see how we got to that. The next thing we would do is what's under the radicand there. And we would have x is equal to -5 plus or minus the square root of 25 minus 24 is 1 all over 2. Now we're going to pause for just a moment and think about the discriminant. That's that number underneath there. If that number is a perfect square number, then you're going to have real rational roots, right? If it's a 0, you're only going to have 1 because you're going to have identical twin roots. So if what's in there is a perfect square number, then you're going to have 2 real rational roots. If what's under there is not a perfect square number, you would have 2 real irrational roots. That means there's a square root attached to them. If it's a 0, you're going to have 2 real identical twin roots. You're going to have 1, you're going to have 2 real identical twin roots, which says there's 1 real root, but you have it twice, you see. And if it was a negative, you would have imaginary roots, okay, because of the square root stuff. So that's a +1. it has a perfect square root. That means we're going to come up with two real rational roots. And a rational number is something you can make a fraction out of. Irrational is like square root or pi or e. Okay? All right? Natural log. So now we're going to do square root 1. And I'll just move it over here. We'll have negative x is equal to negative 5 plus or minus 1 over 2. When you take the square root, you do plus or minus the square root of. And so we don't mess with that plus or minus until the square root has been taken. That's where it comes into effect. And so we say x is equal to negative 5 plus 1 over 2, or x equal negative 5 minus 1 over 2. Understand that? Where and when and why we implement the plus or minus. Negative 5 plus 1 is negative 4 over 2 is negative 2. Negative 5 minus 1 is negative 6 over 2, which is negative 3. Remember, those are the values of x when y equal 0. They are the solutions to the quadratic, the zeros of the quadratic, the roots of the quadratic, the x-intercepts of the graph. Any questions on number 11? So we solved the quadratic using the quadratic formula. Okay? I'm sure you recall that from Algebra 1 and Algebra 2 and geometry. Okay? There you got it. Number 12. The a of the quadratic is 10. The b of the quadratic is negative 1. The c of the quadratic is negative 3. So we have x is equal to the opposite of b. B was a negative 1. So what's the opposite of a negative 1? Positive 1. Anybody see why that's a positive 1? The opposite of b. Plus or minus the square root of b squared. What happens when you intend to square a negative? You have to put it in parentheses square. Minus 4 times my a of 10 times my c of negative 3 all over 2 times my a of 10. And so we've gotten it set up. Remember that we're going to do 3 things to start with. We're going to do this calculation, the square. We're going to do all those multiplied, thinking about signs, and we're going to do that. So we will have x is equal to 1 plus or minus the square root of negative 1 quantity squared is positive 1. 4 times 10 is 40 times 3 is 120. Then we check our signs. The 4 is negative. The 3 is negative. Is that an odd or even number of negatives? There's 2 of them. That's an even number of negatives. When you multiply or divide with an even number of negatives, the answer is positive, so that's a plus. And 2 times 10 is 20. But you understand the odd and even multiplication sign rules. Those will get some folks into trouble right there if you're not careful. We're now going to do the addition underneath the radical. And so we get x is equal to 1 plus or minus square root 121 over 20. It's time to do the square root. Remember, when you do square root, that's where the plus or minus applies. So we're going to have x is equal to 1 plus or minus. What times itself is 121? 11 over 20. So then we apply the plus or minus. X is equal to 1 plus 11 over 20. Or x equal 1 minus 11 over 20. One plus 11 is 12 over 20. 4 will go into both, and you'd get 3/5. 1 minus 11 is negative 10 over 20. Negative 10 over 20 is negative 1/2. If we wrote those solutions as ordered pairs, we would have 3/5 0 and negative 1/2 0. Any questions on number 12? Again, the radicand, the discriminant, was a perfect square. Therefore, we ended up with 2 real rational roots. 2 real rational roots. No square root, no I. 2 real rational roots. Any questions on number 12? Graphically speaking, if there's 2 real rational roots, that means it's going to dip under and come back up, and it's going to hit the x-axis in 2 places, right? Which in this place would have been at positive 3/5 and negative 1/2, which I won't put numbers on there because it's not going to look like it's right if I do. But the idea is, if you have 2 real rational roots, you're going to have 2 places where it hits the x-axis, okay? All right, number 13. Number 13, the a of my quadratic is 2. The b of my quadratic is negative 6. Good. And the c of my quadratic is 1. So x is equal to the opposite of b. B was a negative, so that makes it a positive. The opposite of a negative 6 is a positive 6. Plus or minus the square root of b squared. Remember, if you intend to square a negative, then you have to put it in parentheses square. So we put negative 6 parentheses square. Minus 4 times the a value of 2 times the c value of 1, all over 2 times the a value of 2. Again, we will do the 3 calculations first, remembering that all of that over there is going to go together using sign rules of even or odd numbers of negatives. And so we're going to have x is equal to 6 plus or minus square root of negative 6 quantity squared is positive 36. 4 times 2 is 8 times 1 is 8. The 4 was negative. That's an odd number of negatives. When you multiply or divide with an odd number of negatives, the answer is negative. All over 2 times 2 is 4. So now we're going to do the subtraction. X is equal to 6 plus or minus square root of 36 minus 8 is 28 all over 4. Now, when we look at this radicand in the square root thing, or the discriminant, as we call it in the quadratic formula, we see that that is not a perfect square number. It's a positive, so we're going to have real roots. If it was negative, we would have non-real roots. But those roots are not going to be rational. They're going to have a square root hooked onto them, right? So we're going to have 2 real irrational roots. 2 real irrational roots. Now, they're still going to cross the x-axis twice, just at funny places. It's hard to see places, okay? When we deal with that radical, we have to simplify it. So now we've got to go back to radical simplification rules. How do you simplify square root 28? Well, If we do the prime factorization method, we would divide by 2 and get 14. Divided by 2 is 7. We would do the prime factorization. We would rewrite it as the product of its primes. Since it's square root, we would circle pairs for square root. We would make a new radical, and we'd take one from each set to the outside. What didn't get circled back to the inside. If there was more than one thing outside, we would multiply. If there was more than one thing inside, we would multiply, but there's not. And so square root 28 simplifies to 2 square root 7. You understand that? Now, I need to say the proper math, too, because there's another way to think that. We could say none of the factors of 28 other than 1 may be a perfect square number. 1 times 28, 2 times 14, 4 times 7. 4 is a perfect square number. That's why it wasn't in simplest form. If we could think of the square root of 28 as being the square root of 4 times square root 7, then we could think, well, what times itself is 4? 2. So we get 2 square root 7. That's not any different than thinking that, right? In that 28, there's a 4 and a 7. And the 4 came from that pair of 2, so it popped out. Okay? So we have x is equal to 6 plus or minus 2 square root 7 over 4. We are having irrational roots here, and we have to know how to show those answers. Okay? We see how we got to the bottom red part there. Okay, so we're going to have then x is equal to 6 plus 2 square root 7 over 4, or x equals 6 minus 2 square root 7 over 4. Now, if there is a factor that will go into every term on the top and every term on the bottom, then you can simplify that by dividing every single term by that greatest common factor. Is there a thing that will go into 2, 6, and 4? 2. So 2 gives into all three of those. So 6 divided by 2 is 3. 2 divided by 2 is 1. And 4 divided by 4 is 2. And same thing on the bottom. So that's the simplified version. Again, you could write those as ordered pairs, comma 0 if you wanted to. So we found 2 real irrational roots. 2 real irrational roots. It would still hit the x-axis in 2 points. Okay? Just hard to find ones. Any questions on number 13? This is not something you just put in the calculator and hit enter. You need to work it down to be able to see those simplified radicals you see. Okay? Everybody caught up? All right. Number 14. The a of the quadratic is 3. The b of the quadratic is negative 2. The c of the quadratic is 4. So we get x is equal to the opposite of a negative 2, positive 2, plus or minus the square root of my b, which was a negative, so we want to show it as the negative quantity square, minus 4 times my a of 3 times my c of 4, all over 2 times my a of 3. I'm going to do those same 3 things again, applying sign rules there. X is equal to 2 plus or minus square root of negative 2 quantity squared is positive 4. 4 times 3 is 12 times 4 is 48. The 4 is negative. That's an odd number of negatives. When you multiply or divide with an odd number of negatives, the answer is negative. All over 2 times 3 is 6. But still we got to the blue. Now we're going to do that subtraction. We will have x is equal to 2 plus or minus the square root of negative 44 over 6. If we look at the radicand, which is the discriminant of the quadratic formula, we see that what's under the radical is not a perfect square number, which means there's going to be a square root on the answer, right? Irrational. But it's also a negative, so it's not real either. It's imaginary. So it's going to be irrational and imaginary. Now, if it's, y'all listen to this, if it's irrational and imaginary, then what's it going to look like on the graph? Well, what if it was real roots? You would see where it hit the x-axis. That's if it had two real roots, rational or irrational. What if it had only one real root? It's got identical twins, and it sets on the axis. What if it's imaginary? It never dips below the axis, you see. It has no real x-intercepts that can be graphed, you see. All right, we're going to continue to solve. We have to fix the radical. You've got the 44 divided by 2 is 22, divided by 2 is 11. So you would have a pair of 2's and an 11. From the pair of 2's, you'd pop out a 2. The 11 would go back in, and you'd have 2 square roots of 11. But what about the negative? What's the square root of a negative 1? What's the square root of negative 1? It's I. So we get 2I square root 11. From the negative, we had to pop out an I. Okay? You understand that? You could have thought square root 4 times square root 11, and from the square root 4 you pop out a 2 and get the 2 square root 11, and then throw in the I for the negative, right? Okay? So what we have then is x is equal to 2 plus or minus 2I square root 11 over 6. And I'll let you catch up. There you go. Now, there is a number that will divide into all three of those, right? 2. So we can divide by 2 and get x equal 1 plus or minus 1 I square root 11 over 3. We divided every piece by 2. Then we're going to apply the plus or minus. So we're going to have x is equal to 1 plus or minus I square root 11, or x is equal to 1 plus I square root 11, or x is equal to 1 minus I square root 11. And that would be your two imaginary roots, which you could also write something comma 0, right? Oh, I lost my 3. Over 3, over 3. Thank you. In my mind, I thought, well, we canceled out the denominator. And I didn't look back. I don't know why I thought that. Any questions on that? So we've dealt with real rational roots, we've dealt with real irrational roots, and we've dealt with imaginary roots. Okay? Now we're going to get to some word problems, and let me explain, because you're in pre-calculus and you've probably dealt with physics. Are y'all in physics? Okay, have y'all dealt with gravitational acceleration constant yet? Okay, so this is what we're dealing with a little bit. If you dropped an object off the top of a building, then it's 9.8 meters per second square is the gravitational acceleration constant. In feet per second square, it's negative 16 feet per second square. So this negative 16 in the formula here is the gravitational acceleration constant. And it's negative because you're losing distance above the ground. This is a formula for distance above the ground, right? So this formula that I've put on this particular problem factors in the gravitational acceleration constant in feet per second square. Now, this is initial height, and this is the initial velocity in relationship to time. So this is where it started. This is the push upward. That's ugly. Let me start again. This is where it started. This is the push upward from it being projected. And this is the pull downward due to gravity, right? Negative 16 feet per second squared. So this is a real equation. This isn't just numbers that won't work in the physics world. These are numbers that work in the physics world. Okay? Initial velocity is 80 feet per second. So we have initial height, initial velocity. Remember, distance is equal to what? Rate times time. So that's how far it would be if it weren't for gravity. But then we're going to be losing height because of gravity. Where we started, height gained due to velocity, height lost due to gravity. Okay? Now, these formulas were already given to you, so you didn't actually have to figure all that out, but in physics you will. Okay? In this particular course, I'm giving you the equation to use. So you're just going to write down the given equation. D equal negative 16t squared plus 80t plus 0. And then I'm going to ask you a question. At what 2 times t will the rocket be 64 feet above the ground D? So all you're going to do is plug that in to the formula that I gave you. I just explained it in hopes that when you get to physics, it would help you a bit. So we realize that this is the equation of a quadratic. And we would probably, because we have no idea how weird the answers might be, solve using the quadratic formula. Now, what is the A of my quadratic? Negative 16. What's the B of my quadratic? And what's the C of my quadratic? And those are incorrect answers. Now, why are those incorrect? Standard form of a quadratic is what? Ax squared plus bx plus c equal. That's not equal 0, that's equal 64. So, before you try to decide what your A, B, and C is, you must first set it equal to 0. I missed. Which is getting it in standard form. So we have negative 16t squared plus 80t minus 64 equals 0. Now that it's equal to 0, we can say what the A, B, and C are, right? So the A of the quadratic is negative 16. The B of the quadratic is 80, and the C of the quadratic is negative 64. Make sure that it's in standard form. set equal to 0 before you determine your a, b, and c. Now, once we know the a, b, and c, we can plug it in the quadratic formula. X is equal to the opposite of b, negative 80, plus or minus the square root of my b value squared minus 4 times my a value of negative 16 times my c value of negative 64 all over 2 times my a value of negative 16. And then we would solve. Again, we're going to do those same 3 calculations first, paying particular close attention to the number of signs, odd or even. And so we're going to have x is equal to negative 80 plus or minus the square root of 80 squared is 6,400. And then 4 times 16 times 64 is what? Somebody want to do that? That would be 64 times 64. 4,096. We have a negative, a negative, a negative. That's an odd number of negatives. When you multiply or divide with an odd number of negatives, the answer is negative. So we put a minus there. All over 2 times negative 16 was negative 32. We're now going to do the subtraction. We get x is equal to negative 80 plus or minus the square root of 6,400 minus 4096 is 1,304. That was weird. 2,304 over negative 32. Then we're going to do the square root of 2,304, which is, somebody have that? Square root 2,304, 48. So we have x equal negative 80 plus or minus 48 over negative 32. Then, because we've now taken the square root, we can apply the plus or minus. So we will have x is equal to negative 80 plus 48 over negative 32, or x equal negative 80 minus 48 over negative 32. On the top, we would have negative 32 over negative 32, which is 1 second. In 1 second, it would be 64 feet above the ground. That must be on the way up. And then we would have negative 80 minus 48, which is negative 128 over negative 32, which is 4. So that particular rocket will be 64 feet above the ground 1 second after it's launched and 4 seconds after it's launched. Obviously, the 1 second after it's launched is on the way up, and the 4 seconds after it's launched just on the way down. Okay? Any questions on that? So the rocket was launched, it went up, it came down, and it was 64 feet above the ground after 1 second going up, and after 4 seconds as it was coming down. Okay? Any questions on that? Well, we'll stop there and get the next one on round 3. Appreciate your attention.